We want to solve the system of equations using any method. Let's use the method of elimination, but before we do so, let's clear the fractions from the first equation. Notice right now we have a denominator of 3 and a denominator of 4. We can clear the fractions from the equation by multiplying both sides of the equation by the least common multiple of 3 and 4, which is 12. We'll begin by multiplying both sides of the first equation by 12, and because the second equation doesn't have any fractions, we'll leave the second equation as is. Multiplying the first equation by 12, let's begin by determining 8/3 times 12. If we want 12 divided by 1, notice 3 and 12 share a common factor of 3. There's 1 3 and 3 and 4 3s in 12. And 8 times 4 equals 32. This indicates 8/3 x times 12 is 32x plus, now let's determine 5/4 times 12. Four and 12 share a common factor of 4. There's 1 4 and 4 and 3 4s in 12, giving us 3 times 5, which is 15. 5/4 y times 12 is 15y, which equals on the right, 2 times 12 is 24. Second equation remains the same. And now to eliminate the x terms when we add the equations together, we want the x terms to be opposites. Because we have a 32x in the first equation, we want a negative 32x in the second equation. For the next step, we'll multiply both sides of the second equation by negative 16. Notice negative 16 times 2x will give us a negative 32x. And we'll leave the first equation as is. Multiplying the second equation by negative 16, we have negative 32x minus 32y equals 6 times negative 16 is negative 96. And now we add the equations together. Notice 32x plus negative 32x is 0. 15y plus negative 32y is negative 17y, which is equal to 24 plus negative 96, which is negative 72. To solve for y, we divide both sides by negative 17. Simplifying, we have y equals positive 72 divided by 17. And now we need to perform back substitution to determine the value of x. We can use any equation with x and y. I'm going to go ahead and use this equation here, substitute 72 divided by 17 for y, and solve for x. This gives us 2x plus 2 times 72 divided by 17 equals 6. 2 times 72 divided by 17 equals 144 divided by 17, giving us 2x plus 144 divided by 17 equals 6. Next, we subtract 144 divided by 17 on both sides. Simplifying, we have 2x equals 6 minus 144 divided by 17. Let's work this out on the side. Let's write the difference as 6 divided by 1 minus 144 divided by 17. The least common denominator is 17. We need to multiply 6 by 17 17ths. Notice now we have a common denominator of 17. 6 times 17 is 102, and therefore the numerator is 102 minus 144, which simplifies to negative 42 divided by 17, giving us the equation 2x equals negative 42 divided by 17. And now to solve for x, we might be thinking we should divide both sides by 2, but because we have a fraction on the right, instead of dividing by 2, let's multiply both sides by 1/2. On the left, 1/2 times 2 is 1, 1 times x is x. We have x equals. On the right, we can simplify before multiplying. 2 and 42 share a common factor of 2. There's 1 2 and 2, and 21 2s and 42. Just be careful, this is really negative 21. Multiplying, we have negative 21 17ths. This indicates the system has one solution, and the solution is the ordered pair negative 21/17, comma 72/17. Before we go, let's verify this graphically. To do this, we will graph both linear equations in Desmos and locate the point of intersection. I've already entered the linear equations in cell 1 and cell 2. I've also entered the x and y values to get the decimal approximations, because we will only see the decimal approximations for the point of intersection. Clicking on the point of intersection on the right, comparing the decimal approximations to the exact values, the graph does verify our answer is correct. I hope you found this helpful.